Hello guys, hopefully everyone is fine. In today's video, we are going to discuss the concept of knapsack problem using dynamic programming. So when you're talking about dynamic programming, it means we will be using the concept of tables to solve it. We have certain options. So what is knapsack problem? You have to fill knapsack or knapsack bag in such a way such that all items are put on such that not all items, such that maximum items are put on the bag with maximum profit. Guys, maximum profit is the main important part out of this entire part. So how this whole process works out, let's say I'll take one example. I'll take a particular example. Example is that we have got items. We have got the profit, and we have got weight. So we have got items, knapsack capacity, 8, right? Knapsack capacity is given. So guys, if I have to solve it using dynamic programming, let me tell you that in dynamic programming, the knapsack capacity is a very important point out of this. We will put it in the form of column. So I'll be creating a particular table for this, and we have a knapsack capacity which will be acting as our table only, right? And we will put the values in the form of that. And importantly, since we are talking about dynamic programming, we will add zeroth item. It does not have any weightage, but it will help in calculation. And zero item is having zero profit, obviously. So that's what we have to start with. We will have all the values starting from 0, 1, 2, 3, 4, 5, 6, let's say 7 and 8. This we are putting all the 4 items. So all the 4 items are zeroth item. This is zeroth item. This is first item. This is first item. This is second item. This is zeroth. First, second, third, and fourth items accordingly. So that's what we have to do, right? So we have total knapsack capacity, which is acting as the column parameter. We have knapsack capacity, which is 8. So this is capacity 0, 1, 2, 3, 4, 5, 6, 7, and 8. Then we are having the items such as this is zeroth item, this is first item, this is second item, this is third item, and this is fourth item. So we have taken all the items as such. This is knapsack capacity weight 0, 1, 2, 3, 4, 5, 6, 7, and 8. And now I have to pull. First item, if I'm talking about zeroth item, it will have zero weight as well as zero profit. So this is never going to count. And zero weight, we are having no profits as such. So we are not putting the values accordingly. Now, whatever these values are, these all are profit values we are putting. Now, see, let me tell you a constraint when we are solving this problem. Guys, if we are putting first item in the bag, let's say if only first item is included in the bag, then only one option is there, which is one, right? If I'm talking about the second item, so in second item, there are three possibilities. Either you can put first item, which is already in the bag, or you can put the second item, or you can put option 1 or option 2. Similarly, with third item, if third item is going to be put up, the first two are already in the bag, or it's up to you whether you want to keep first item or second item or third item, or possibility of first and second. You can put both values. You can put second and third also, or you can put first and third also. So this is possibilities. And if you are talking about fourth item, or you can even put first, second, and third, like this is a possibility. If you're putting fourth item, so you either putting first, second, third, fourth, or options such as first, second, second, third, fourth, first, fourth, all the values accordingly, right? So this is something that we need to understand and get the answers accordingly. So the profit values are supposed to be added in this way. Now, let me just get the entire result as such. So how the result is going to be calculated. So if you are putting first item in the bag, firstly, zero item is there. It will not have any profit. So I'll put all the values as zero. This is an initializer. Now the first item gets inserted into the bag. Just check what is the weight of that item. Weight of the item is 2. So whenever I reach weight 2, I have to fill the profit value of item 1. The profit value of item 1 is 1. I have put up. So what is the previous value? 0. That's what dynamic programming is. Now I've put up 1. So guys, even if I reach weight 3, 4, 5, 6, 7, 8, I have to insert item number 1 in the bag. So whenever I reach item weight 3, profit will still be 1. Profit 1, 1, 1, 1, and 1. So all the profit will be 1 even if I reach weight 8, because only first item is supposed to be concerned. Now, second item comes into play. When second item comes, there is possibility either first item can be in the bag, or second item can be in the bag, or either first and second both in the bag. Now, first check the item second weight. So the item second is there and its weight is 3. So whenever I reach weight 3, what is the profit? The profit is 2. Now I can put item 1 in the bag, but item 1 profit is 1. So 1 or 2, I have to choose the best profit out of it. Clearly, best profit is 2. Now, weight 2, at weight 2, what will be the profit? At weight 2, weight 3, we haven't reached anything because weight 3 profit is 2. Over here, weight 3 is there, profit 2 is there, but when weight 2 is there, profit 1 is there of this item. Now, weight 4, at weight 4, I can either put profit 1, why? Because that is weight 2, what item 1, or I can put weight, we have weight 3 and the profit is 2. So maximum profit is 2 compared when two items are compared. Now guys, just add their weight. 2 plus 3 becomes 5. When two items are inserted in the bag, so what is the combined profit? The combined profit is 3. Perfect. I can write that. I can take that profit. When weight 6 is there, profit 3 will be there. 3, 3. I cannot increase more profit because maximum profit of inserting item 1 or 2 is 1 and 2 is 3. So I did insert them. I got profit 1 when weight 2 is there. I got profit as 2 when weight 3 is there. I got profit of first and 2, which is 3 profit when weight 5 I have reached. At 4, we will have profit 2 only. So that's what we have got. Now, the third item is going to get inserted. So third item possibilities are either first item can be inserted in the back, or second item only, or third item only, or I can insert first and second. This is one possibility. Or I can insert second and third, another possibility. Or I can insert first and third. This is another possibility. Or another possibility is first and second and third. Now, guys, if I combine first, second, and third weight, 2 plus 3, which is 5, plus 4, which is 9, and knapsack capacity over here is 8. Knapsack capacity is 8. Now, how does this entire scenario going to work out? So in this particular scenario, I cannot insert all the items in the bag. So what I will do? I have to solve this particular thing. So let's talk about when weight 1 is there. When weight 1 is there, no item can be inserted. When weight 2 is there, only first item can be inserted, whose profit is 1. When weight 3 is there, only second item is going to be inserted, whose weight is 2. Fine. Now, when weight 4 is there, there is a possibility I can insert. When fourth weight is there, I can insert item 3. So this is also a possibility whose profit is 5. I'm writing that. Okay, when 5 weight is reached, what is the maximum profit I can get? So when 5 weight is reached, 2 plus 3 becomes 5, and 1 plus 2 is profit is 3. But guys, I am getting maximum profit for weight 4 also, with inclusion of only third item. So only third item is giving more profit than inserting first and second. So I will put 5 over here. Now, when weight 6 is reached, it means I can include fourth and 4 plus 2, which is 6. And what is the maximum profit I'm getting? 5 plus 1, which is 6. So I'm putting 6 over here. Okay, so when weight 7 is reached, when I include second and third item, 4 plus 3 is 7, 2 plus 5 profit is 7 also. Okay, when weight 8 is reached, so either I can write 4 plus 3 is 7, or 4 plus 2, which is 6, 2 plus 3 is 5, I cannot insert all the items. So what is the maximum profit I have got till now, which is 7, I'm putting 7 over here. Now, comes the next important part. I'm including weight 5. So guys, at weight 5, a maximum profit I can reach is 6. So did you get this at weight 5? No, at weight 5 we got 5 only. So we are putting this, right? So at weight 4, maximum profit we are getting 4. So I'm putting all the values accordingly. Now, let's just try to get certain answers. When weight 6 is reached, so either I can include item 4, or I can include item third and item first. So we are getting maximum profit at 6. I'm putting 6 over here. Now at weight 7, I can include item fourth and item first. 5 plus 2, 7. 1 plus 6, the profit is also 7. So guys, when weight 8 is obtained, so in weight 8, fourth item possibilities are either item 1 or item 2 or item 3 or item 4 or first, second, or second, third, or third, fourth, or fourth, first, or 1, 2, 3. All the possibilities, guys. Now, when 8 weight is reached, I can include weight 8 with this fourth item, and weight 8 with 5 plus 3 weight is 8 weight, and profit is 6 plus 2, which is 8. So 8 profit I have got from item 2 and 4. These are the items which are contributing to the maximum profit. Hence, if I want to conclude, item 2 and 4 contributed to maximum profit, which is 8. Hence, both items should be included in the bag. So if you like this video, kindly like, share, and subscribe. Kindly support us in this initiative. If you have any doubts, put it on comment box. Thank you very, very much.